My name is StaceySandy. I will be presenting my project presentation on the Colorado K-12 financial transparency data. This project is for the fulfillment of my final course and the completion towards my Master of Data Science degree at Regis University. My project overview is that I want to explore and learn what are the school expenses that impact our children's educational needs. What are the contributing factors of the various expenses? What variables are impacting the data reported? The objective of this project and primary research question is to explore how financial expenditures are being spent across K-12 schools in Colorado. My exploratory data science approach will conduct potential ways to hopefully answer these research questions. In the past academic year, my kindergarten son has brought home 5 different fundraisers. Unfortunately, I'm unclear where the multiple fundraiser funding is going, what the funding is for, and how fundraisers feed into the school. Hopefully, I can learn more about why fundraising is important or necessary multiple times a year. As for my data sources, I will be working with the Colorado K-12 financial transparency data, as I mentioned. It's actually found at the Colorado Department of Education website, which is located right here. And then the complete data set can be found at the link, which is located right here. There is also an available interactive website link that you can conduct direct school financial searches on your own, and it is right here. As always, there are some project considerations. For one, the data collected is from the 2017 to 2018 fiscal year. The fiscal year accounts for a 12-month period from July 1st through June 30th. In this case, the data is from July 1st, 2017 through June 30th, 2018. Although there is current readily available data to our disposal, the Financial Policies and Procedures Chart of Accounts for fiscal year 2017, 2018, and 2019 may not actually coincide with the given data set provided from the Colorado K-12 Financial Transparency website. Therefore, this project only examines codes that will only refer to those applicable and found within the 2016 to 2017 Financial Policies and Procedure Chart of Accounts, which is actually the one that we will be focusing on primarily. At least this is what is advised from the Colorado K-12 Financial Transparency website FAQ. As for the outline of the presentation, first I'll discuss the findings from my exploratory data analysis, and we'll look at the top 5 most used financial codes within each category. We must bear in mind, though, that these numbers, even though they look like numerical values, the numbers are in fact categorical values which identify to financial codes within the financial chart of accounts. Next, I'll follow with some insightful visualizations to give breadth to our data. Then we'll lead into the machine learning algorithm used, and we'll end with my findings and lessons learned. All right, let's jump right into the exploratory data analysis. I should mention this took a great fraction of my time. I have acted as a sponge to absorb each and every aspect that I can within this 8-week period on the subject matter relating to the financial chart of accounts. And for something that seems simple, the process became an accelerated research methods course on financial coding and the meaning behind those codes within the data set. So I'm going to try my best to avoid details and only highlight the 5 most frequently used financial codes within each category available for each unique identifying code. For the top 5 most used district codes within the Colorado K-12 Financial Transparency Dataset is Denver County, followed by Jefferson County, then Douglas County, Adams-Wald 5-star schools, and lastly Fremont. Keep in mind the number value to the left of the description is just the code for the unique identifier for the district code. These values are based on count values within the data set. So this value here is actually a code for Denver County. This is for Jefferson County, Douglas County, Adams County, and Fremont County. The top 5 used administrative unit codes fall into the similar categories: Denver County, Jefferson County, Douglas County, Adams 12 5-star schools, and now Larimer. So we're seeing a bit of a trend here between district code and an administrative unit. The top 5 school codes used fall into the categories of Adams City High School, Kearney Middle School, Adams City Middle School, Central Elementary School, and Rose Hill Elementary School, which ironically, all of these schools are located within the city of Commerce City. Of the top 5 used fund codes, it includes the General Fund, Governmental Designated Purpose Grants Fund, Charter School Fund, Food Service Fund, and Pupil Activity Service Revenue Fund. What's interestingly is that Food Service Fund is amongst the top 5 used fund codes, and I actually just got to check back for my son's lunch account this week because school's not in service. Okay, the top 5 most used location codes are a bit more complex, as code fund values are placed between a range of numbers such as like 100 to 199, 200 to 299, 300 to 399, and so on. So the first of the most used location codes fall into elementary school, followed by high schools and then centralized services. Middle school or junior high schools follows in 4th as most used code, and location code 0 is the top 5 as well, which is still very unclear. So the 6th top used location code beyond the 4th and the 0 value code is a combination school, which is identified as schools with permanent multiple instruction, such as elementary to middle schools and K through 12 schools. Then the top 5 used program codes in the dataset is very interesting, as the value 0 is the most commonly used program code. There are actually 39,439 zero value program codes within the dataset. The 0 program code is then followed by support services such as school administrations, general elementary education, and then support services again with instructional staff, and the last top 5 used program code is special education. For the top 5 used object source codes, it accounts for expenditures on salaries, and then employee benefits come in second, followed by supplies and other purchase services. Then expenses on travel, registration, and entry is the last amongst the object source balance code. Lastly, the amount sense column is the one and only column value in the dataset that is a real number value or a true integer. It's not a means to a categorical item within the financial transparency dataset. The amount value is defined as the amount that is used as the data element, capturing the specific amount being reported for the unique combination of reporting elements. Of the amount value spent, there is the highest amount, which is $1,633,140,000. This encompasses the district code Denver County, the admin unit Denver, the general fund unit, and the district-wide cost location code in the specific interfund loan payable object source code, while the least amount value reflects a negative $1,614,800,000. And this accounts for, again, a district code Denver County, admin unit Denver, general fund again, and district-wide costs within the interfund accounts payable object source code. Moving on to visualizations. Allow me to say trying to create visualizations for categorical data in the form of numbers is very difficult. These are highly categorical values, and placing those values into an X and Y plot or graphical format is very limiting since the numbers aren't actual numbers. Remember, all but one column is an actual real numerical value, so this caused me great complications, and trying to create interesting visualizations was a bit of a challenge, so please forgive my basic plotting efforts. To begin with, here is a correlation matrix on a set of categorical values. Of those correlations, the highest correlation is actually between district code and admin unit, which is 0.38, and it's right here. And then the next correlation we have is district code and location code, which is 0.064, which is not very high, but there is a correlation that is positive and not negative. The next one is fund code and amount sense. Again, not very high, but it's there at 0.012. These correlations are hardly a good example of evident correlations between the financial codes in the data set, but we'll go ahead and continue on and look at amount sense or amount spent within categorical financial codes. Looking at fund code and amount sense, we can see that fund code 10 and fund code 40 is one of the highest amounts of values spent within amount sense. And there's also a large disparity both positively and negatively when you look at fund 10, because it kind of goes all the way up to 1.5 and negative 1.5. And these are kind of concerns of outliers and anomalies. Looking at administrative unit and amount sense, we can see the most values fall within the 10,000 and 20,000 administrative units for the amount sense spent. But there is also some disparity again where we see some positive and then some more negative. And these are kind of concerns of outliers and anomalies once again. For district code and amount sense, there is commonly used district codes between 0 and 2000, and we can also again see a disparity between positive and negative values, another concern of outliers and anomalies. As for object source balance, it looks like it's a bit difficult to see which exact code is an outlier to the overall object source code amongst the amount spent. We are seeing a few positive and negative points. There's some over here at the left and then some in the middle here, but these just indicate some more outliers and anomalies. Looking at school code against amount spent, we see 0 as the most commonly used value, and this is something of questionable uncertainty. Looking at location code and amount sense, we see the code location 800 seems to be the most commonly used. Again, we see positive and negative values, which can be of concern. Moving on to K&N machine learning algorithms, if visualization. In summary, these are my findings just as they are. K&N proved even more when converting categorical values to objects, conducting one-hot encoding methods, and splitting the dataset into training and test sets was not easy. I learned running the training set through a model of 10K values showed very little accuracy, as well as running it through 25K values showed also little accuracy, each within 0.12 and 0.129. Just to follow up on the K&N, I did actually run the K values for 100, 200, and 500. So feel free to look back at my Jupyter notebook. You'll see the accuracy score. It barely even moved and increased in any way. To finalize my overall project findings, I learned that the K through 12 financial transparency is rather hazy and very ambiguous. We learned Denver County, Jefferson County, Douglas County, and Adams 12 5-star schools are among some of the most commonly used codes in the district and administrative unit categories. The top 5 used school codes actually fell within the same city of Commerce City, which included Adams City High School, Kearney Middle School, Adams City Middle School, Central Elementary School, and Rose Hill Elementary School. The top 5 expenditures by fund codes included General Fund, Governmental Designated Purpose Grants, Charter School Fund, Food Service, and Pupil Activity Special Revenue Fund. It's evident that General Fund is the most commonly used fund, but there seems to be some sort of discrepancy from the vague usage of the General Fund. More importantly, the program codes used within the financial chart of accounts shows that the value 0 is the most commonly used value. This is kind of questionable. Then at most, we learn that the object source code accounts for salaries, employee benefits, supplies, other purchased services, and travel/registration and entrance are amongst those top codes. When we look back at the research questions, did I come to some answer? Well, I really wanted to expand on what the school expenses that impact our children's educational needs, and what are the contributing factors of various expenses, what variables are impacting the data reported. But aside from these findings, the amount spent value was an astronomical amount that gave very little value as to what really is spent across Colorado K-12 schools. I'm really left defeated with little to no answers, but really more questions than what I began with. So some of the lessons I learned is I continue to learn and will always learn that exploratory data analysis takes a great amount of time to synthesize. Number 2, categorical data can be a big pain. It's heart-wrenching at times. I learned and actually understood some complex data that was hard to deal with, but it was a good learning experience. I also learned to embrace the KISS, the keep it simple, stupid idea. In final, I think that I got some answers, but I really feel that I learned financing, accounting, and codes related to expenses may not be my forte. In any case, there's still so much to learn, so this doesn't end, because I do want to continue to find out what's going on in regards to the Colorado financial expenditures for education. And I guess to that end, go ahead and look at my references further in depth in my Markdown or my project repository back on GitHub. These are my last words here as a graduate degree requirement for the completion of a Master of Science here at Regis University. So thank you for listening.